Hello everyone. Today we have our 23rd meetup, AI for Medical Prognosis. My name is Dovydas, and so this is what I do. I am currently the president of the Artificial Intelligence Association of Lithuania. I'm also a machine learning team lead at Vinted and also a founder of Tribe of AI. So if you want to reach out to me, this is my LinkedIn. Please go ahead and do that, or use our platform. It's again another best way to reach out to me. These are our sponsors. So big thanks to Tech Consult, Vilnius Tech Park, and Vinted for helping us make these meetups and all in all make Tribe of AI continue. So these sponsors make it happen. Our agenda for today is, first of all, we are going to talk a little bit about what is Tribe of AI, what do we do, what's like status update of our current projects and the things which we do. Then we go to the presentation AI for medical prognosis. Pretty interesting topic. So this the last one was about medical diagnosis. Today we have a presentation about medical prognosis, and most likely we will continue for the third. The next month we are going to end everything with medical treatment. Finally, at the end, we are going to do the networking session. By the way, let me enable the audience tools so you can go ahead and ask questions. Please don't ask questions on YouTube because I cannot see them. Go ahead and use the link which you see on the slides and ask questions there. So this way I can see your questions, and at the end we can discuss about topics related to AI for medical prognosis and also Tribe of AI, whatever Tribe of AI does in general. So all the stuff that you want to talk about, we can all do that at the end. We are trying to to make the best of this. It's no longer quarantine period, but we are still going to do this and the next meeting online. Most likely the next one is going to be back to Vilnius Tech Park, and for now, let's make the best of it. Let's use the tools which Google provides for us, and let's have a discussion and networking there. So let's start with the introduction to Tribe of AI. Tribe of AI is mainly consists of three things which we do. So we have meetups, we have AI Bootcamp, and we have AI Academy. So meetups is the first, the easiest example, because today is our 5th remote meetup. It's already 23rd meetup all in all. And the next one was, as I previously mentioned, the next meetup is also going to be online, but the next one will be on site. So 25th, can't wait to see you real in person. It's always a little bit tricky to do these online meetings because I don't get to interact with the audience pretty much at all. The audience tools is the only way for me to get the feedback from you. But 25th meetup is again, can't wait to get back to Vilnius Tech Park and continue with the meetings. Also, most likely we are going to do more joint events with Lithuanian Association of Artificial Intelligence. We might do maybe not the next one, but the next one we might also do it together with the association. So fun times ahead. Let's talk a little bit about the bootcamp. So there are no new stuff here. So if you're following Tribe of AI, the bootcamp finished in the spring, and it took us more than 9 months to do the full bootcamp. It was really intense, 3 meetings per week, 3 hours per meeting, and all in all 9 people have survived / graduated. Bootcamp 2.0 is it was planned to start in September, but due to the situation we are postponing it. I really hope that we can do it this year, so hopefully we won't have the second wave of corona, but of course if we have that, we cannot start the bootcamp 2.0, but I really hope that we can start the second iteration of the bootcamp at the end of this year, most likely December. So that's all I know so far. Let me move to the academy. So AI Academy is going strong. We actually have so between this and the last meetup, we have 3 or 4 classes. I don't actually 3 classes have graduated. So there is a lot of activity here. Some people who were not super involved while we had meetings on site now have maybe it's easier for them to do it online, but I'm very happy overall that the participation overall is really good in the AI Academy, and I am thinking I have a lot of plans what we can do with the AI Academy. So let me introduce the AI Academy a little bit more. So the idea is that you can start learning AI with no prerequisites. If you have prerequisites, we also have you covered. And if you are already a machine learning expert, or if you're a Python expert, we have special classes. You don't start from the beginning. You start at your appropriate level, and then you're joining a team, and you're together with the team. You're continuing your journey towards the AI mastery. So that's the main idea, is that even if you have no prerequisites, you can still participate in the AI Academy. The principles are that we do not create content. There are lots of good content creators around, and maybe there are no perfect content creators, but there are a lot of pretty decent ones. And if we can take the best out of the best content creators, we can form a really strong course, in addition to having mentors which keep you on track. This is a very powerful combination, having the content, having the mentors, and orienting towards achieving actual results, towards successfully learning stuff and being able to apply it on real projects. That's the main idea of AI Academy. So we are, as I mentioned, we are very practical. We try to maximize your success, and we try to use agile and lean principles in our learning methods. So what happens if you have some AI experience? Maybe you are a machine learning engineer, maybe you are a data scientist. So we have various different classes. S class is for the people who are already really good at artificial intelligence, machine learning, deep learning, all of these things. So we focus on trying to find interesting problems to solve, form teams, or even these proto startups, and start to work on these interesting problems. So that's the S class. If you're not there yet, you can join the A class. The A class is, by the way, actually we are starting, I haven't announced it yet, but we are going to start the A class. So the last B class have already graduated, and it's me right now bottlenecking, not announcing the formation of the A class. but it's going to start this month. I'm going to announce it most likely this week. And so the next A class is starting, and if you have deep learning fundamentals, if you want to move forward, if you want to do more advanced deep learning, learn more advanced deep learning, and then join the S class, it's the perfect time to do that. If you're not there, if you don't have deep learning fundamentals, then you can join the B class. We won't have the B class like in the near future, but what we will have a C class, because the current D class have graduated, and we are again forming a new C class. We are actually joining the D class team who have graduated, and if you are data scientist who wants to learn machine learning, this is a perfect time to get on board. Then we are also starting a new E class, so people who have Python fundamentals or who are like strong programmers but have like little Python experience, this is a perfect class to join. So E class is all about more advanced Python stuff. If you're a developer, you can pick up the fundamentals like in a few days, and then continue with the rest of the team on more advanced Python stuff. So we are also having the E class, so pretty much unique timing. I don't think that this ever happened, or maybe happened like once after the initial foundation of AI Academy. So we have 3 classes which are going to be open for about a month, and you can join in and continue learning that already with the team who have progress from the lower class. So the structure of AI Academy is that we commit to learn for at least 8 hours per week. We meet every Saturday. We learn at home. That means we learn on our own time, like watching the videos, reading the articles, doing the exercises. And during the meetings, we talk about the most important things that we learned. We think about best practices. It's like machine learning and especially deep learning are unique fields because the best practices keep changing so often. Things that they're in scientific papers like 3 years ago are like today they are almost like comically outdated. So you really cannot stop learning at any point in time. You have to, so even the best courses, even the best books, they have some outdated things which needs to be corrected, and therefore we have mentors to do that. So the strengths of, as people have told me, and I see it, the strengths of our academy is that we embrace the social aspect. Nothing helps you learn more than a group of peers who are learning the same thing, who are interested in the same thing, with whom you can share your knowledge and experience, whom you can help, and finally, whom you can make meaningful connections with. So all of these, the social aspect is super important for learning, super important for later, embracing these connections, and with people whom you know and whom you trust, you can start thinking about your startups, or start meaningfully looking for a job. It's so much easier if you have somebody to talk to. It's so much easier if you have other people who have done it. It's an enormous help. This by using the social aspect, you get an enormous advantage over pretty much everybody else. So one new thing which we have started to do, so previously everything in Tribal.ai was free. We didn't have any paid options, and there was for about maybe 3 months I was gathering ideas and thinking how to ensure that people are more motivated, and that we have that we understand the value which we get from Tribal.ai. So finally, we have launched a paid option very recently, by the way. So you have finally an option to support and help Tribe of AI. If you're joining the new teams, you'll have two options. So if you want to, like as I mentioned, like support Tribe of AI, you can choose the paid option. It's a simple subscription service, so it works pretty much like every single like subscription service, Netflix, Spotify, iCloud, whatever you choose. If you don't want to pay, that's always also an option, but I need you to like prove your motivation otherwise, so you have to write a motivational letter. What's the end result? Is that like a freemium model that if you choose the free option, you're somehow limited? Actually, that's not the case. It's just like the gatekeeping option. So once you're in a team, it really matter if you paid or if you chose a team, you get this exactly the same treatment as like everybody else. So that's the new update. That's the thing that changed the AI Academy. So previously my slides always had like these three pillars: meetups, bootcamps, academy. So finally I have like the like foundation on which everything stands, the platform. So the platform continuously keeps giving me value. I was, to be honest, at first quite reluctant because it costs quite a bit to maintain the platform. But I mean, like both in like time and money. But I think that like today I can pretty much certainly say that platform provides enormous value for our community. It's like so much easier to structure the content. It's so much easier to like update the stuff. It's like you can link to the relevant examples. You can like find the right courses. You can in the Tribe of AI platform. So the platform is open, platform is free. Please join the platform if you haven't done so. So hopefully you have, because everything like this event was the first one which fully embraced the platform event features. So hopefully you had a chance to take a look at it. So now it's time to talk about AI for medical prognosis. And like this presentation is again an inspiration of AI for medicine specialization on Coursera. I have been doing this Coursera specialization for like I have actually finished it, but like maybe the last month. But it was very interesting. It was very on topic. What was interesting for me, because of the whole corona situation, I was interested in how we can use artificial intelligence for medical purposes. The specialization, by the way, if you have done like the other Andrew Yang specialization, artificial intelligence for deep learning, the deep learning specialization, I mean, you might be a little bit disappointed. It's at best a supportive specialization. The original, the deep learning specialization, is like really a masterpiece work. AI for medical prognosis is a decent course, but it's nowhere near in quality and in terms of material close to the deep learning specialization. That said, so what I'm saying is I had to, like, initially I thought that I can give you most, like I can provide you the most important parts, but I ended up researching quite a bit of more extra material for this medical prognosis, and I try to provide my sources as links at the end. So let's start with the plan. So today we are going to talk about diagnosis versus prognosis. What's the difference between these two things? We'll remember what we talked about regarding the diagnosis in the previous meetup. Also, we are going to talk about building prognostic models, then about the evaluation and improvement of these prognostic models. Finally, we'll talk about survival models and the time dimension, how time impacts like these models. So let's start with diagnosis versus prognosis. So diagnosis, we can like classify the medical AI problems into these two parts. We have diagnosis and we have prognosis. So diagnosis is all we classify those who have corona versus those who don't. So it's all about making correct diagnosis. Prognosis is, on the other hand, is about predicting the future. So we are predicting the risk of death. We are predicting the risk of a heart attack, the risk of a stroke, the risk of cancer. It's all about will this thing happen in a few years? What's the risk of this thing happening in the next 10 years? Also, in addition to that, we are also predicting the health of the patients and the development of the disease. So we might have like stage of a disease, and we want to estimate what's we want to predict what's going to be the stage of a disease at some point in the future. So predicting and prognosis, prognosis is all about making predictions about the future in regards to the patient's health or the development of the disease. So why prognosis is useful? So mainly because we want to estimate the risk of illness. We also want to estimate the patient's survival probabilities. We also want to guide treatment. So for example, who should get the treatment first? If we have two patients that they both have the disease, but their development of the disease might be very different, and if we have like some kind of transplant, so we need to know for whom to make the transplant first, and who can wait for a couple of months with low probability of dying. So it's I'm always a little bit uncomfortable talking about these very important things such as death and diseases, and it's still a little bit of a cultural thing, because at work we don't deal with we actually use very similar models for clients, for clients making a purchase in some date in the future, or for what takes for an item to be sold in the next 10 days or whatever. But AI for medicine, in my mind, is super useful because of that, because it tackles the largest problems which we have for making these decisions, like life and death decisions. It's amazing that we can use the technology to the technologies which we use for other stuff. We can use the same ideas specifically for medical applications. So let's move forward. I want to give you some examples of prognostic tasks. By the way, not all of these examples here are prognostic tasks. You have a task right now to think about which of these are prognostic tasks and which of these are not. And the next slide is going to be the correct answer. So let's start. I'm going to read all of these. I'll give you a minute to think about it, and then make your guess, out of these 5 examples, which ones are prognostic tasks and which one are not. So using retinal scanner to diagnose retinopathy. Estimate the patient's lung cancer risk recurrence after therapy. Forecast of a patient with a heart is risk estimation. How risky, what's the probability of this recurrence happening if we apply therapy. So let's say we might want to compare the outcomes with therapy and without therapy. The third one is forecasting 5-year survival probability of a patient with a heart condition. So that's very easy. Survival probability forecasting should be clear that it's a prognostic task. It's all about the future. The time is, there is a time in the task description. There is an ask to predict probability, and it should be clear that it's a prognostic task. Next one, recommending more active lifestyle to patients with high genetic cardiovascular risk. We are not predicting anything. We are just pretty much that's a little bit of a trick question, because it's just a recommendation. You don't need to do any kind of model. You just can recommend it and be done with it. You don't need machine learning to do that. The next one, predicting if the patient has cancer using CT scans. Again, clearly a diagnostic task. We are predicting, but we are not predicting the future. We are predicting the current state. We are doing the CT scan, and we need to predict, like, true or false, the patient has cancer. So we have to make this binary decision. Let's talk about building the prognostic models. So there are some examples of popular prognostic models which they have names which are used in practice, and they're quite simple, but they're kind of good. They serve as a good starting point. So first of all, we have these CHA DS VASC model for atrial fibrillation. So by the way, atrial fibrillation is pretty common abnormal heart rhythm that can lead to a stroke, and we can use this. I can actually have a table here, so how this CHA DS VASC score looks like. So we measure these features. So let's say the feature can be congestive heart failure or left ventricular systolic dysfunction. If it's true, then we add 1 point. Hypertension, if that's true, we add 1 point. If age is greater than 75, you add 2 points. And we pretty much sum them up. We sum up these conditions, these features, and we get a score. Based on the score, we can use the tables to find what's the risk of dying in 1 year. I'm pretty sure that CHA DS VASC is having a heart attack within the next year. There are also other scores, such as MELD score for liver disease, ASCVD score for this illness. So by the way, I provided the links. There's a pretty amazing medical model calculator. So you can just it's very interactive. You can let me try it out. So we have these fields here. You can add your age. You can select if you are male or female. You can select what's the other parameters, and you get the risk. And here you have a point which says what's the risk of a stroke for you. And here they are using the Swedish atrial fibrillation cohort study to say what was the risk score for this cohort. If you just game the system and want to select the highest possible values, as I of course did, to see the upper bound, you see that the risk can be quite great if you have all of these risk factors. So that's an example. We have the other ones are very similar. I mean the MELD score and ASCVD score. So let's continue. Yeah, I need to exit this. screen. Yep, some bit of technical difficulties. Here we go. It's always a risk if you have this touch bar on this setup. Kind of forgot that it's never a good idea to do it full screen, because it doesn't really allow you to escape from it. But now we're good. So let's continue. We talked about the CHA DS VASC score. Let's continue with the evaluating and improving prognostic models. So the evaluation of prognostic models, pretty much the first thing which you have to understand that it's pretty much always a pairwise comparison. You need to have pairs to know how well the model performs on this pair, and make the decision based on intuitively you want to have higher score for the riskier or the patient who had the worst outcome, and the lower risk score for patients who have lower or more benign outcomes. So to do that, we the medical community have this special names for it. We have first of all, we care about the permissible pairs. So the first condition is that the outcomes should be different. And I guess it should be pretty, when you think about it, you should arrive to a conclusion that if the outcomes are the same, we cannot really do anything with this pair, because we don't know if, let's say we have two patients and both of them are healthy. So we cannot really make any inference about our features or about our model, because the outcomes are just the same. So once we have different outcomes, we can have three types of pairs. So the first pair is a concordant pair. So if the patient with the higher risk score, got the worse outcome, then we have a concordant pair. If the patient with the higher risk score did not get the worse outcome, so it's equal or better, then it's called a non-concordant pair. So I kind of left it out because it's just exactly the opposite. If the risk, if our model calculated the risk exactly the same for both of these patients, then we just have a risk tie, which is pretty much, imagine a model which says which gives exactly the same risk score for every single patient, and it's pretty much a model full of risk ties. Of course, it's much better than a model who always gives you incorrect decisions, but it's not as good as a model which gives you always always the concordant pairs. So how do we actually compare two models if you have these permissible pairs, concordant pairs, risk ties? What's the procedure here? We have this what's called the C index. So the C index is calculated by counting the number of concordant pairs, adding all the risk ties. However, the number of risk ties should be divided by 2 or multiplied by 0.5, and we divide this cumulative sum by all the permissible pairs. So this gives us a C index, and C index will let you compare two types of models to decide which model is the best, based you can use this as a metric to decide which model is the best. once you have calculated the C index, you know, like now you have a way to measure your models. You have a way to actually do meaningful improvements. So how to improve your prognostic model? Pretty much there are regular machine learning procedures. So the first one is hyperparameter tuning. Pretty much it's basic machine learning. You should always be doing hyperparameter tuning if you're dealing with tabular data, or unless you're dealing with like insanely high number of data, then maybe you should try to still find a way to do hyperparameter tuning. But in pretty much all cases, that's a necessary step. But hyperparameter tuning requires you to know a metric which you're trying to optimize for. So this once you have the C index as a metric, you can tune your hyperparameters. You can overfitting, of course, is in, again, regular machine learning, the most common problems in making these prognostic models. So once you have that, you can always add feature engineering, and these are if you would look at the two models which I gave in as example previously, they use the feature engineering not very extensively, but as an important step. So in these types of models, log transforms, interaction terms, some other transformations are pretty common, and adding them up to your model should be an integral part of the procedure. Finally, the last part is comparing distributions for train, validation, and test data sets. And by the way, I guess all of these things might sound on paper as trivial, and yeah, of course I'm doing that. But even large companies such as Google sometimes make mistakes. One of the there was a famous diabetic retinopathy article when Google created a model which detected this illness, and they just didn't account for different distributions. So they trained their model, their distribution was different for their train, validation, and test data sets, different from what we used the model for. And due to this difference in distribution, their model was barely better than random. So I don't have it as a link, but you can pretty easily find articles about it. And it's always if you make a mistake in, I don't know, retail or platform or whatever type of business, it's usually costs you money. If you make a mistake in medical AI, it can cost you lives, or it can give you it can result in unnecessary human suffering. So it's really, really important to get these models right, to do not to skip these important steps to improve your models. One thing which is different and which is very not super unique to just medical AI, but it's really big part of AI in medicine, is handling missing data. And so first of all, we have these three types how data can be missing. So the first type is what's called missing completely at random. So when the data or the feature, it can be multiple features or a single feature. Let's say we have I don't know, blood pressure as a feature, and let's say that the doctor did not record the blood pressure on a patient based on a coin flip. So let's say the doctor just during their normal working day, for every patient flips a coin, and if a coin lands on heads, the doctor does not record the blood pressure. If it lands on tails, then they record the blood pressure. So that's what would be called missing completely at random. That means the distributions, the train, test, and validation distributions should be very close, and like pretty much just the randomness should impact it. So this is the best types of missing data. They shouldn't hurt your model too bad. The other ones are a little bit more nasty. So the missing at random, by the way, the names here, I'm not a fan of these names. I just like, again, in general, machine learning has so much bad naming. I think this is a good example of pretty confusing naming schemes. So the missing at random is that we have missing feature data, which both has like random and not random components. So there is some condition to randomness. So let's say the doctor doesn't, let's give the same doctor who flips the coins, and let's say the doctor is very I don't know, the doctor doesn't want to risk like flipping the coin for old patients. She only cares, she very much cares for old people, and she says, oh, I'll record like this blood pressure for all the old patients, but for the young ones, they are healthy as we are, I'm going to do that, continue doing that at random. So there is a condition. The doctor might have some kind of age threshold. Maybe if the patient is older than like 65 years old, she always records the blood pressure. If the patient is younger than 65, she flips a coin, and again, the same procedure applies. If it lands on heads, she records it. If it lands on tails, she doesn't record it. Finally, we have missing not at random. So this missing not at random is yet again different. It also has a condition, but this condition is not observed. So for example, if you record like if the doctor decides like, oh, I'm going to record it always, but it's an unusually busy day, and the doctor checks if there are patients waiting, and if there are patients waiting, she flips a coin, and then again, same procedure. If there are no patients waiting, she always records. And this is an unobserved variable. So if previously we had age, which is part of our feature set, so here age is not part of our feature set. So this is the most dangerous type of missing value. So how to deal with these missing values? The most important thing is to compare the distributions. We need to understand that like you might get biased results based of why the data was missing, and which of the procedure resulted this. Was it missing completely at random? Was it missing at random? Or was it missing not at random? So it depends on these types of like the risks depends on these types of missingness type, and they should be like, you need data science skills to investigate each specific case and make a decision about what's the best way to impute the data. By the way, what you shouldn't be doing is you shouldn't be dropping the rows with missing values, because that would lead most likely to even bigger biases than just using a simple imputation. I think that like the usual machine learning methods, such as adding an extra row to say was it imputed, and using either the most common value or building a separate logistic regression or linear regression, depending on the type of feature which you're imputing, building a separate model to fill it in, I think those are pretty decent and robust against all types of missing data, but again, I don't want to provide this as a rule for you can always be safe, because you need to think about each concrete case and try to use your best judgment, trying to find out facts why it was missing, and use the most appropriate imputation method based on that. Let's move to the survivor models and the time dimension. So we are actually the survivor models are actually an extension of prognostic models. By the way, don't confuse the two. If the prognostic models are models which just predict something at some point in the future, survivor models are like models which can predict something at any point in the future. So we are a more generalized version of prognostic models. So how likely am I to survive the next 5-10 years? How likely is the disease to come back in the next 5-10 years? So pretty much everything then we have at some point in the future, and we need to define the probability of this thing happening at some point in the future. Very important part of a survivor model is the survival function. So the survival function defines the probability of survival of a patient over time. So usually graph going down. If like at the beginning of the time dimension we have very high survival probability, it's continuing to drop towards like the more time passes, it's not as likely that the patient survives. It can be, by the way, these models can be applied for various different applications. It's not just like, for me, what was really interesting that I can use these models for even in my work. I can predict like when the item will be solved. What's the probability of it being solved like immediately when it was uploaded to our platform? Yeah, very little. What's the probability of it being solved like in the next 24 hours? Yeah, that depends on the item. I can build a model for this item which will give me this survival function, which will tell me what's the probability of this item surviving the next 24 hours. And then you can extend the model, like since the survival function is defined at every point, at every time point t, you know, like what's the probability of it surviving 24 hours, 5 days, 7 days, 30 days, 1 year. You can give probabilities for all of these time points t in the future. Finally, we have a hazard function. So hazard function is like you can imagine that as a thing related to survival function. It tells you there that the higher the hazard function is at some point time t, the higher drop in the survival function we have. So let's like it really benefits a chart here, but I don't have it. So I'll try to give you an example which should illustrate my point. So imagine having an item which, imagine having a patient which, yeah, let me think, or let's get back to the item. Imagine having an item which is very likely to be, it's very hot, like, but it's very popular just this month. Let's say we have like some kind of maybe carnival or some kind of occasion, and the highest hazard in quotes, so the highest probability of sale, happens when the item is just uploaded. So maybe tomorrow is the carnival and nobody's going to buy the item the day after tomorrow. So we have this huge spike in hazard values in the first 24 hours, and when the hazard function drops like drops a lot and maybe becomes even flat. So no one is going to buy the item for the next year until the carnival comes again, and maybe this like special carnival clothing is going to be again very popular the last month before the carnival. So the hazard function would look like that. It would be very high initially, then drop very much to zero, and then only like or close to zero, and then start to build up before this next event. So you can imagine how the survival function will look like. So the survival function will start again at like 1 probability of survival. It will have like immediate drop because the hazard function is very high. So that means the survival function is dropping quite rapidly. Then it will flatten out because there is very little risk that the item will be sold in the next year, and then it will start to decline again, closing the next year's carnival. So that's just an example which I came up on the spot to showcase that it's not only you don't only need to use these models for medical applications. You can use it for whatever work you're doing with machine learning. It's like it's very unique. Machine learning is very unique because we can transfer a lot of knowledge from one domain to the other. I guess my favorite example is maybe survival models are like very interesting, but my favorite example are UNets. Actually, UNets started as a medical deep learning thing, and UNets are the tool. Everybody uses UNets for all the segmentation tasks which we do, but it started out as this niche thing, only applicable to like medical artificial intelligence, not published in any major machine learning journals, just like for useful for medical AI. And later, because it was a good idea and somebody decided, yeah, we can use that for pretty much generally, not only for medical AI, only later it became popular, and like today it's very popular. So that's it for the presentation. These are the resources. So of course the most important resource is the AI for medical prognosis Coursera course. We also have the MD Calc, so that's the one which I've shown you for with AI, and new tools in data and AI. These are interesting articles that help me out with this presentation. Now it's time for your questions and answers, and again, go ahead and like if you have any question regarding today's topic or anything in general about Tribe of AI, we can stay here for a few minutes and chat. So I have switched to am I the only one who had bad connection? So hopefully I see at least 2 people had bad connection. Sorry to hear that. I hope it's not my internet. It wasn't, to be honest, behaving too good today, so hopefully the recording was okay. I'll wait a couple of minutes for more questions to pop up. I don't see any more questions. So if you have, like, we can always use the Tribe of AI platform to get more to like discuss about it, to discuss about these topics a little bit later. So it doesn't have to be synced right now. Oh, I got one more question. So how big the F group for AI Academy is going to be? In general, I try, like previously, it was previously the groups were about started this with about 16 people, because we had like always about half of the people didn't survive till the end of the class. So if I wanted to have about 8 active students, I had to start with 16. Now since we have like these more motivational checks in place, so I hope that we are going to start with 8 people, and maybe like from 7 to 9 people. And I really like the groups being small, because it's all about individual. It's all about individual attention, and if you have more than 8 people, it's pretty hard to like constantly check on everybody. So I think we are going to start with 8 people. By the way, the F class is not going to start in the near future, so probably not this month. Most likely the F class is going to start next month. We are starting I think C class, B class, and E class, so no F class. We have one more question. What are the main difficulties? Donatus asks this question. What are the main difficulties in getting AI solutions to actual medical markets? Oh, it's a big topic. My friends from the AI Association could answer it so much better. But in short, there are so many regulations. Like, there are multiple reasons. There are like legal reasons. There are data sharing reasons. The data is very sensitive in medical artificial intelligence. So you're not sure if you trained all. There can be a difference in I don't know, everything. There's also this legal to get a lot of certification, limit what your models. So I think that that's all for today. If you have any more questions, so please use the chat in the event page on Tribe of AI platform. We can discuss about it, about this presentation until the next one comes along next month. And I'll update you about the upcoming classes, the new classes which you can participate on, like with the AI Academy, as soon as possible. So most likely I'll try to do it in the weekend this week. It was a pleasure having you all here. I hope the presentation was useful.